We're going to pause for a moment in our investigating of the different types of rocks in the rock cycle and start applying our knowledge to our rock story problems by investigating the 3 different types of igneous rock that are in the Glasshouse Mountains. So here you have a table for task 2 where you have to look at 3 different igneous rocks, and it says type, name and images, and describe those rocks and discuss what you think happened to produce those rocks. And the 3 different types of igneous rocks are actually found in our Glasshouse Mountains picture, which I'm going to show you now. In Connect, you'll see this page, which is an embedded website called ThingLink. And there's our Glasshouse Mountains picture, and I have all these little links on here to different websites and pictures and videos to help you learn about the rocks in those areas. Now over here it says that our igneous rocks are in our key are coloured yellow, our sedimentary are coloured this skin colour here, and metamorphic are this orange. So over here we have the 3 yellows: tuff, which is also known as ash stone, rhyolite sediment, which is just broken down rhyolite, and underneath here, you can't see it very well, is something called trachyte. And here they are in the Glasshouse Mountains. There's my tuff, there's my trachyte down there deep, and there's my rhyolite up the top. And we also have rhyolite on an angle here on the sides. So first of all, you just need to investigate these by looking up pictures of the rocks as whole, the rocks when you look at them up close at their crystals, and then investigate where these types of rocks normally form and under what conditions, so that you can start to tell a bit of the story of the Glasshouse Mountains. So first of all, you can use these links here to actually look at videos and find pictures of what these rocks would look like up close and personal. And you can use these links here too to also read a bit more about how each of these different rocks may have formed. And you can put all of these and your own findings into your document. So to help you know what to do, I've actually given an example using a rock that's not actually in this, not actually in your assignment, called basalt. So the very first thing I want you to do is I want you to go and research the rocks. In this case, we'd have what have we got? We've got tuff, and we've got rhyolite, and we've got trachyte. And you have to collect a whole heap of images, and in these images I want you not to just collect images of the whole rocks, but I want rock images and microscopic images, so of the crystals and stuff up close. And I'm going to show you how to insert them in a minute, and I want them inserted as images into these Google Docs here, so you get a picture of what these rocks look like. Because remember, you have to look at their crystal structure and stuff to get an idea of whether they're extrusive or intrusive, whether they had time to interlock their crystals, whether or not basically they were born either inside the volcano or outside of it. So here's some examples. Say we are researching basalt instead of those 3. What you need to do is find some pictures of basalt, but make sure you have the right to use those pictures before you go and stick it in your Google Doc. Now the way you make sure you have rights to use them is to use the search tools in Google. You click Tools and you click Usage Rights, and you ask it to only show you pictures that allow you to use them for non-commercial use. So here we go down here, labelled for non-commercial reuse, and you will end up with a selection of pictures which you can use for free. Then I've gone and found a picture that I know I can use for free, like this one here. Make sure you know it is actually the rock you're looking for, because sometimes other rocks turn up in these searches. Make sure the name is in there. And you need to just copy its URL to stick it into your Google Doc and to give it some recognition of where you got that image from. So click on it, open up the full picture, and you copy its URL there to stick it into your document. Now to insert it into your document, you simply have to click on the area where you're adding the images, so right here, and tell Google to insert an image by URL, paste your copied URL, and then you've got it in there. Now you can either stick the URL, because you know you're allowed to use it, underneath that picture there so that we know exactly where it came from. Or if you go a bit further, if you're using Wikipedia or Wikimedia, you can actually paste in the attribution for that picture. Essentially, if you use Wikipedia, it makes things an awful lot easier when it comes to finding images. So the next part of this video is going to show you how to use Wikimedia to do this process, because it actually tells you what to glue in here for attribution so that it's all completely legal. So just hang on a second. Here is my favorite picture site, Wikipedia, or its little partnership site, Wikimedia. When you have any pictures on here, they actually have to give people permission to use them. So when you go into those pictures, if you open them in a media viewer like this and click more details about this file, then it actually tells you how to use it legally. So there's the same picture. You say, I want to use this file on the internet. That's why it's got the little World Wide Web symbol there. You can even download it if you want. And when you click that, this comes up. So here again is the file URL for the picture. Don't use page URL, that goes to Wikimedia, this whole thing here. You want the file URL for that picture. And here is attribution. Now, although this is a really bad example of one, this is actually what you click to copy and paste underneath your picture to show that you've legally used this picture. So you're going to use these two options here to actually put those pictures in and cover yourself for any copyright problems. So first of all, copy the file URL, stick it in your Google Doc, come back to here, copy the attribution, and then you stick that in down below. So here, this is where I've stuck the attribution from Wikipedia. Now this one is a really bad example, but most of them it actually will tell you who actually took the photo and where they came from and everything like that. If you do that, you are actually completely fulfilling all college requirements for using media ethically. You have to put pictures of those 3 rocks in here. If you're really excited about it, you can do a few. But the next thing I want you to do is give me a microscopic view of your rock so that you can look at the crystals. Because if you can't see the crystals, then you don't exactly know what it looks like completely, and you can't have a really good guess of how it's made. You can also go and take pictures of these rocks in our rock specimens over in the cupboard as well. So here we go and look at crystals. To get a picture of these rocks up close, you can do 2 things. You can ask for microscopic and the word of your rock that you're looking at, or thin section. In other words, you're wanting to look at it up close and personal, and it will bring up these sort of pictures. Now, this is rocks up close. Now, yes, again, like last time, you have to make sure it is basalt. So if I click on this one, let's have a look. Olivine basalt, thin section. And as soon as you do that, you can actually have a look and you can see, yes, it's got lots of little crystals and stuff in there, but they're not all growing in together. Okay, they actually haven't had enough time to grow together, because basalt is one of the ones that's an extrusive rock and it cools really quickly. And it's got all this black stuff here, which is actually like it's like a very glassy lava, that is really, really black, and it's so dark that it hasn't even had time to really form crystals. It's got tiny, tiny little specks in there. So this is a perfect picture of basalt up close. Again, do the same as you did before, where you actually copy the picture, copy the attribution and stick it into your document so that you're putting together a picture view of the 3 rocks in the Glasshouse Mountains. Once you've done that, you're going to take some time to actually write out your own description. So what are the grains like? Does it have large crystals? Or are they small crystals? Or do they interlock together? Does it show any signs of whether it's extrusive or intrusive? And from that, can you give me some conclusions? Okay, now not just conclusions from just those pictures that you've got, but also draw on the information from your experiment. What does that tell you, given what you learned from your experiment, about the rock and how it was formed? Was it one that was formed under slow cooling conditions? Was it one that was formed under fast cool conditions? And what evidence do you have based on your experiment and those pictures to justify your conclusion? Okay, you must relate it back to the evidence that you had in your pictures and in your experiment for full marks. And that is task 2 in a nutshell. You just have to do that for the 3 different rocks, which are igneous rocks in the Glasshouse Mountains. Okay, tuff, rhyolite and trachyte.